When was the last time you used your smartphone to get into a meeting, or to see a client, or to go to the store, or to eat lunch? And when was the last time you used a paper map? Because you want more than just a paper map. You want updated maps, you want map directions, you want trip durations, you want live updates, and you want to know the closest lunch spot, and you want to know if it's amazing. So in essence, you want real-time information so that you can make smarter, faster decisions to be more productive. So your smartphone apps these days are like digital assistants. You input your tasks, your meetings, your times, your locations. They will turn and tell you, Ernest, it's going to take you 20 minutes longer to go down the street due to heavy traffic. Bring an umbrella because it's going to rain all day. And by the way, your team beat the Yankees last night. So you expect live personal information in your own schedule. And if you don't, your kids certainly do. And your clients are expecting the same thing. So why wouldn't they expect something similar in the work function? Because in paraphrasing Mike Tully here, it's not about remote sensing pixels or elevation anymore. It's about providing information and solutions so that you can make faster and smarter decisions. So that's why I'm excited to talk to you today about onboard real-time processing, on specifically what I know, which is in-flight ortho mapping, generated in the air as captured. So imagine what kind of decisions that a mission commander could make if they had real-time map lines. So there are 6 things that made it possible. The first thing is real-time direct georeferencing, which is the ability to georeference a pixel or a point without the need for any ground control. So this is the most important aspect because in-flight ortho is built on this foundation or core technology. So it's more than just a really accurate position orientation from a GNSS IMU. It's ensuring that what you measure in the air, and all that accuracy translates to the sensors, their calibration, computer synchronization, the transformations to represent the ground without any ground reference points and in real time. Which brings me to the second point, which is the need for calibrated metric sensors. You want repeatable results over time. And for me, as long as you have stable calibrated sensors, you can map with a visible, a SWIR, a thermal, a LiDAR, a radar, whatever makes your, or a combination of them, whatever makes your business unique. So now, the direct georeferencing accuracy you need is relative to the application and the sensor for it. So in-flight ortho, we're not talking engineering grade mapping here. Integration is super important because all these computers need to talk and listen to each other and need to be fast enough to process each other's information in real time. So this leads me to the third thing, which is all about computer performance advancements, which plays a huge part of onboard processing. In essence, a bunch of sensors or computers record data, others tell them to record data, and all these need to be at data sizes that the latest processors can handle at the same time, which then gets combined into other computers for georeferencing, map generation, and transfer to data storage at minimal power consumption levels. So that's a lot of communication you need to get right in real time. Data transfer technologies are just as important which is why smaller or medium sensors are used for onboard processing. So this is very interesting because computer advancements also bring miniaturization, which opens the door to many new possibilities. The fourth thing I want to talk about is satellite-based corrective surfaces. After all, the more accuracy you have or you can get, the better your final product. So right now, Trimble's OmniStar will give you about 10 centimeter position accuracy globally. A new service will give you, a new service called Centerpoint RTX from Trimble will give you 4 centimeters globally. So this is real-time precise point positioning service. Realistically, these are best case scenarios. So you're likely looking at decimeter level positioning here. So then again, what new applications would be just fine with decimeter level mapping? What kind of applications do you have if you had just sub-meter level mapping? So let's take all that we've spoken about so far, account for the availability of existing digital terrain models, and let's throw all this into a real-time ortho engine, and the result is the ability to do in-flight ortho mapping with no ground control. So the question is, what would in-flight ortho do for you or for anyone? Well, the easy answer is the ability to do in-flight quality control, so what if you could see a problem in your project in the air as it's captured? What if your flight crew wouldn't have to wait for headquarters or to land to make a judgment call on quality? So what if they could make that call themselves in the air? Right? So how much more productive could you be? How much more profitable could you be? So these are questions that you could begin answering. And then there's, of course, time-critical mapping, right, or emergency response, just like it was used for Superstorm Sandy. And, of course, military operations. But what excites me the most is what's going to happen in the commercial world. The availability of automated fast maps will allow you to detect temporal changes in a given area. So this opens mapping, I believe, to people who didn't use maps before, especially when the delivery, the cost, and the frequency is going to change. So what's next for onboard real-time processing? Well, just like with your smartphone, we want more than just an updated map. We want map directions, right? So luckily, we don't have to look very far to get answers. In fact, we simply need to look at what we're post-processing right now. So one of those things could be object-based image analysis, right, and automated classification. So here you have a suburb, and here you have all the rooftops and vegetation classified automatically. Add an elevation component and other layers of data, and you could extract volumes of structures, vegetation types by heights, roads, cars, etc., and compare temporal changes, on-the-fly analysis. So I think the path for onboard real-time processing is set. The future is about providing information and solutions. And just like you do with your smartphone, you want to make smarter and faster decisions. Mr. Moderator, panelists, membership, thank you very much.